Not every problem in statistics has dozens of possible outcomes. Sometimes life is much simpler. Did your login succeed? Did the email arrive? Did the customer buy the product? Yes or no. Whenever there's only one trial with only two possible outcomes, you're looking at a Bernoulli distribution. Bernoulli distributions are everywhere. Did the light turn on? Did Face ID unlock your phone? Did the payment succeed? Is this image a cat? Every one of these asks the same question. Did one experiment end in success or failure? Different words. Exactly the same mathematical idea. Imagine building an AI model. One predicts spam, another predicts fraud, another predicts disease. Instead of inventing different labels every time, statistics uses one simple language. Success becomes 1, failure becomes 0. That tiny decision makes mathematics and machine learning a whole lot easier. Let's build our first Bernoulli distribution. We'll flip one fair coin. We'll define heads as success and tails as failure. We choose what success means. Statistics doesn't decide it for us. Since the coin is fair, both outcomes are equally likely. Success happens 50% of the time. Failure happens 50% of the time. That's a Bernoulli distribution. Here's a common misconception. Many people think Bernoulli means 50-50. It doesn't. Suppose a professional basketball player makes 90% of their free throws. Success has probability 0.9. Failure has probability 0.1. It's still a Bernoulli distribution because there's still only one trial and only two possible outcomes. One probability goes up, the other comes down, because together they must always add up to 1. You might think we need two probabilities, one for success, one for failure. But every probability distribution must add up to 1. So if success already has probability p, failure doesn't need its own variable. Whatever success doesn't take, failure gets. That's why Bernoulli distributions only need one parameter, p. Watch what happens as p changes. When p equals 0, success never happens. When p equals 0.5, both outcomes are equally likely. When p equals 1, success happens every single time. One number completely describes the entire Bernoulli distribution. Don't memorize this formula, let's read it like a story. X is the outcome, 0 or 1. If the outcome is success, the probability is p. If the outcome is failure, the probability is 1 minus p. That's all the Bernoulli formula is saying. Let's solve one. The probability of making the shot our success is 0.8. What's the probability of failure? Since probabilities must add up to 1, failure is simply 1 minus 0.8, which equals 0.2. No complicated mathematics, just one simple idea. Bernoulli distributions are everywhere in machine learning. Binary classification models answer questions like, is this email spam? Will this customer click? Does this image contain a cat? Every prediction is fundamentally a Bernoulli problem. One outcome is success, the other, failure. Let's summarize. Bernoulli describes one trial. There are only two outcomes. Success is labeled 1, failure is labeled 0. Success has probability p, and failure automatically has probability 1 minus p. A login succeeds with probability 0.95. What's the probability it fails? 0.05. True or false? A Bernoulli distribution always has a 50% chance of success. False. Which of these is Bernoulli? Rolling a die or checking whether Face ID unlocks your phone? The answer is Face ID. Remember it like this. One trial, two outcomes. Success equals p, failure equals 1 minus p Bernoulli. Bernoulli answers one question. What happens in one trial? But what if we repeat that trial 10 times, 20 times, 100 times? Now we're no longer interested in a single success. We're interested in how many successes occur. That's exactly what the binomial distribution studies.